Hey everyone, hope we're all doing good. Druha, first, you are on it. I'll take a look at it. Ooh, do we have a related rates here? 100 liters of pure water, MT equals 0. Solution of salt concentration of 0.8 kg per liter is added at a rate of 7 liters per minute. Solution is kept thoroughly mixed and is drained from the tank at a rate of 5 liters. How much salt is in the tank in kilograms after 30 minutes? Okay. It's been a while since I've done a related rates problem, so let's see if I can remember how these are done. I remember the concept. I just remember if you do it in concentration or an actual amount of salt. So we'll figure that out if I make a mistake, I guess. So how we usually represent these problems is just with a simple drawing of a tank with an in pipe. What the heck am I drawing? In and out pipe. The tank initially contains 100 liters of pure water. When T equals 0, we have 100 L pure wa. Then a salt solution 0.8 kg per L of salt is coming in at a rate of 7 liters per minute. And then coming out, we have the mixed solution at a rate of 5 liters per minute. Okay. And so I think we're going to do this in terms of concentration, not actual amount of salt. I think you have to. So it feels like you would have to. If actually no, let me. I wanted to do without looking anything up for some reason, but let me just actually. No, that's not what I want to do. What was that? Oh, I was holding the wrong key. Ugh. Oh, I wish there was an easier way to manage my windows in OBS like this. As far as I know, there's like an automated way to do this like window cropping stuff that I'm doing. Yeah, I should actually look into that. I need to do it all the time. I assume it'll be in Calculus 1, maybe? I don't think it'll be in business applications. Maybe in... No? Maybe it will be in business applications. Maybe it'll be in the first part of derivatives. Related rates, there we go. They have to have the tank problem here. Tank problem is one of the most like... Really? They have to have a tank problem somewhere here. Hey, it's first skin. I'm good. How about you? Wouldn't be in business applications. Maybe in differential equations. Here we go. Okay. And Q of T is the actual amount. Flow rate times concentration. Okay, that's good to know. That's all I really needed to, or that's all I like wanted to find out is how we express it in terms of amount or concentration. It's going to be concentration. You don't have any simple questions? Oh, okay. I guess I got lucky. Okay, so this person uses A for the amount of salt. At time t. So we don't know what A of t is directly, that's what we want to find, but we do know the rate that A of t is changing. So we can define dA by dt as rate in minus rate out. The rate in is simple. We have 0.8 concentration, kg per L times 7 liters per minute. Oops. And the units here are going to make sense because the liters cancel, so we get kilograms per minute, and dA is the kilograms per minute. Like, that's the units that we want. So this is the rate in. Minus the rate out. We have a very difficult math question. I'll hear it, but I won't do it. Because if you're saying it's difficult, it's probably impossible for me. Over here, we don't know the amount of salt, or we don't know the concentration of salt rather directly. We have defined the amount of salt as A, and concentration is amount divided by volume. And the volume in the tank, we're getting 7 liters in and only getting 5 liters out. So that means the tank is going to be gradually filling up by 2 liters per minute. The initial value is 100 liters, so this is a linear equation. 100 plus 2t. So that means the amount of salt we're going to have is A, whatever the amount of salt in the tank happens to be at a time t, over the volume, 100 plus 2t, kg and L. So we still the same exact units, just it looks a bit different as a function now. Times the rate out, which is still just 5L per minute. Okay. So we can get, we've done our check with the units. We can kind of get rid of them now for the sake of doing the problem. Suggest an open but not continuous map from R to R. No clue. The answer would never figure it out yourself. Oh, geez. Okay. Uh, 0.8 times 7, 5.6. Technically, it's kilograms per minute, but I'm going to stop writing the units at this point. A over 100 plus 2t times 5. That doesn't really simplify, so we'll get 5a over 100 plus 2t dA by dt. In this, maybe there is a way to separate it. There probably isn't. It doesn't matter. I'm going to solve with an integrating factor. So I'm going to rewrite it a bit differently to put in a more familiar format. I'm going to add this term to both sides, and I'm going to put the a off to the side. 5 over 100 plus 2ta is equal to 5.6. Now we need the integrating factor, which is... I'm going to get this mixed up. Hey, Skirtle! It's math time. Cute emo. How's it going with you, Skirtle? It involves a famous Cantor set. I believe it. Watching my stream makes you feel smart. Oh yeah, I'll take it. It's my turn to be dumb right now because I need to remember how to solve this differential equation. Sus. Okay, so yeah, e to the p, which is that function. Okay. And I realized that I covered it up. Just give me 1 second to copy this down. Mu is e to the integral of 5 over 100 plus 2t dt. And the final answer is 1 over mu times the integral of mu times q. Or they use g. Oh, I see. I mean, honestly, that's kind of a funny burn. I didn't even think about it that way. If you were making fun of me and I realized it, I would have laughed. I interpreted that as like basically the way that you said. Okay. So when we integrate 5 over 100 plus 2t, I guess you do if you want, you can do a u sub. I'm just going to do the u sub in my head. The 5 will come out front. 5 ln. Oh, wait, no. When you do the u sub, you have to multiply by 1/2. 5 over 2 ln 100 plus 2t. Okay. And, well, plus c. So now a equals 1. Well, actually, let's actually simplify this. Actually, Zatchap, thank you so much for the raid. Welcome in, everyone. What were you streaming? Things are going on, big maths. Luigi, thanks for the follow. Theo Duke, I'm probably saying that wrong, but welcome in. Salty problem, yep. I'm not going to do the plus c yet. I might be slightly wrong with not doing it yet, but we'll find out. The e and the ln basically kind of cancel, so 100 plus 2t. The 5 over 2 stays up top, which is what I mean by kind of cancel. Realian86, welcome in. Okay, look, it's a Bell pronunciation. Good. Normally I butcher people's names, so it's a nice first for me. Quiet Mercenary, thank you for the follow. I hope the stream was good. Yeah, for everyone who's new, my streams are normally me kind of looking around on the internet for math questions to answer. All times I get stuck and I can't do them, but it's still fun to look at. Right now I'm working on one from Reddit. It's a related rates problem, so I set up a differential equation to model it, and I'm trying to solve it right now. And yeah, I also play video games as well, but today's a math day for me. I might play some games after, but it's always depending on how I feel. Yeah, thanks so much again for the raid. And I suppose it might be Zach AP. I'm sorry if I said Zatchap, and that wasn't right. So maybe I did already butcher your name, but anyway, thank you so much again. Okay, but if we solve this first order linear differential equation with an integrating factor, we do 1 over mu. So 1 over 100 plus 2t to the 5 over 2. It's going to be annoying when we have to integrate this next part, times the integral of 5.6 times that. Actually, no, it won't be that annoying to integrate. 5 over 2 dt. Okay. Just thinking. When we integrate this, we need to do a u sub. So let me write the first part. Just write that factor there first. 100 plus 2t to the 5 over 2. And then I'll just do brackets for whatever the result is for the integral. Let's actually drag the 5.6 out front. Times 5. Actually, my marker is fading. Let me switch to red. Markers are kind of crappy. Oh no, Skirtle. I didn't interpret it that way. And even if it was, I probably would have laughed because it'd be a funny one. But I appreciate it, but that's definitely not how I took it anyway. But thank you for just like clarifying. Okay, so basically we're going to do u equals 100 plus 2t. So we're going to integrate u to the 5 over 2 du. We do need a 1/2 out front because of the u sub. Then we integrate u to the 5 over 2, you get u to the 7 over 2, so you multiply by 2 over 7. Okay. And then the original thing back. Plus 2t, this time to the 7 over 2. Oops, bracket. And that should be plus c. I don't know if we want 2 plus c's. I feel like we just do the 1. I'm running out of room. Let me come up here. Okay. So we got to simplify that mess there. Let's bring this so it's up in the numerator, I guess, and multiply these like fractions together. So 5.6 over 7 from doing those fractions times that. 100 plus 2t to the 7 over 2. And then you have plus c times 5.6, but 5.6 times c, I'm just going to call it c again, because who cares? And then in the denominator, you have 100 plus 2t. Over 2. I definitely want to split these up into 2 fractions. Arberlin, welcome in. Thanks for coming by. Bit late. You were getting coffee? Ooh, I love coffee. Math type? Hell yeah. Okay, so yeah, let's split them into 2 fractions. Let's make sure that these constants were fine the way that they are, and I think they are. So we get 5.6, 100 plus 2t to the 7 over 2, over 7, 100 plus 2t to the 5 over 2, plus c over the denominator. And I'm splitting it up this way because I want to get the cancellation with these two. So we get 7 over 2 minus 5 over 2 is 2 over 2, which is just 1. So 5.6 over 7, 100 plus 2t to the power of 1, plus c over 100 plus 2t to the 5 over 2. That's a crappy fraction bar, but just pretend that's a good fraction bar. You're more of a discrete guy? Yeah, I'm sorry, but we're definitely mortal enemies. I do not like discrete math. Oh, Johnny boy, well, welcome in as well. What math field are you using to solve this problem? I'm using calculus. Well, I guess differential equations, but this is normally taught in a calculus like 1 class. Right now in this stage though, it's more algebra because I've already gone past the calculus part for the step that I'm on. Graph theory? Oh, I'm glad that there's someone who likes it because the graph theory is helpful, but I don't like graph theory. The little bit that I do know about it. I just have a, just for background, I have a bachelor's in applied math, so I was kind of trying to avoid a lot of like the classes like that. Points and lines done. For me, it's not that simple. Okay, at this point, we need to get an initial condition in to figure out what C is. That's our next step. So we know at time t equals 0, the water in the tank is pure. So the amount of salt, A, should be 0. So if we have the point 0, 0, I'll plug 0 in for A and 0 in for T, and let's see what we get for C. 0 equals 5.6 over 7 times 100 plus C over 100 to 5 over 2. And that actually is a clean number because the square root of 100 is 10. Ugh. I don't want to write underneath like the browser right there. Ooh, I have your respect. All right. Well, thank you, Berlin. 5.6 times 100 is 560, question mark, yes. Over 7, we have a negative sign, so we subtracted it over. C, square root of 100 is 10, to the power of 5 is 10,000. Multiply each side by 10,000. Wow, that's going to be a weird number. C equals minus 560 with 5 more zeros. 1, 2, 3, 4, 5 over 7. Jeez. 56 million over 7. Does that actually simplify? 7 goes into 56? 5, 6, 7, 8? Oh, it does. That's only negative 8 million now. Right? Actually, if there's the wrong number of zeros, that might not work. Let me, Wolfram Alpha save me. 5, 6, 1, 2, 3, 1, 2, 3, divided by 7. And you guys can't see it quite right. Okay, it is 8 million. I just wanted to check that quickly. Oh, and Arberlin, thanks for the follow. Okay. So we know what our C is, even it's so it's a janky number, but we got negative 8 million. I'm assuming this is right. Anyway, I more just want to see what the answer was. I'm probably not going to give the person the actual answer to the problem. But these problems, like, I just enjoy doing this type of math, so I got to see it through to the end rather than just giving them the starting point. 100 plus 2t, so I'm going from this step, but plugging in C. Minus 8 million over 100 plus 2t to the 5 over 2. Oh my god, what am I doing? You know, this would look a bit cleaner with a negative exponent. I think I like the look of that more. 1, 2, 3, 1, 2, 3. 100 plus 2t to the minus. Oh no. My stupid line is in the way. My good old spaghetti math. Okay. The final part of the question was how much salt is in the tank after 30 minutes. So we take this function, plug in 30. Yes, because t is in minutes. And that's our answer. So let's do that in Wolfram Alpha. Get everything in floating point numbers by now. First kind of while leaving your head. Jeez. I respect you then too. Okay, so we're going to take the function that we came up with there, plug in 30. That'll be the final answer to this person's problem. 5.6 over 7. Hopefully it's a reasonable number. 100 plus 2t minus 1, 2, 3, 1, 2, 3. 100 plus 2t to the minus 5 over 2 with t equals 30. 103.295 kilograms. Basically, well, I mean, the level of water in the tank will be increasing. So, I mean, that is a lot of salt, but that seems like a reasonable number. Okay, so I did all that work, but really all I had to check was their setup here. Let me make sure that no one has replied in the meantime. No, okay. So they did 0.8 times 7, good. Minus a over 100 times 5. Okay, so they're actually nearly there. Their error here was they did a over 100, and the 100 comes from the volume of water in the tank initially, but it didn't account for the volume of water in the tank increasing over time because you have 7 liters coming in per minute and only 5 liters going out. Your is nearly correct, but a over 100 part assumes that the volume. Since 7L per minute of solution coming in and only 5L per minute coming out, tank is gradually filling rate of 2L per minute. To model this, 100 plus 2t, initial amount in the tank, and 2 is the rate of increase. d by dt equals 0.8 times 7 minus a over 100 plus 2t times 5. Let me put that in brackets to make it clear where the 5 goes there. I then solve this with an integrating factor and find a function involving different powers of 100 plus 2t. Okay. I want to give them a hint for what solution they should get without saying the actual solution. Ah, that's a pun, because salt solution. Anyway. But yeah, let's post this. Hopefully it helps the person. If they get back, we'll respond then. Algebra and limits problem. Question B in the imager link. All right. Oh God, this browser's taking forever. Really? Open a new tab. Okay, there. Okay, so they're talking about part B, which is down here. So the limit of x approaches 0 of ln 1 plus x minus x over e to the x minus 1 minus x. You L'Hospitals. Oh, they're doing it separately. I was wondering how this entire thing boiled down to just that, but no, this is the top part only. So 1 over 1 plus x minus 1, good. E to the x minus 1 for the bottom, good. Let me write this on the board and just, they say the bottom, wait. 1 plus x in the final step in your work is supposed to become 1 plus x squared. I wish I said the entire expression, but let's just, oh, bye marker. Just solve it for myself. find out. Wait, oh, sorry for the booty cam. Or maybe not, so, sorry. Depending on how you reacted to it, I guess. Okay. I'm just going to copy down the problem, and then I'm going to take away the browser completely. Give me 1 minute. Limit as x approaches 0, ln 1 plus x minus x over e to the x minus 1 minus x. Okay. Let's just work this out for ourselves. First, I start off with L'Hopital's. That derives to 1 over 1 plus x. That derives to minus 1. E to the x is e to the x. Minus 1 is 0. Minus x is minus 1. So here they say something about 1 plus x squared. I assume... Really? Can we just plug? No, we can't just plug it into here because you get 0 in the denominator still. So I think we get a common denominator and then bring the denominator down. I don't think we're going to get 1 plus x squared. So 1 over 1 plus x, and then that 1 is equivalent to 1 plus x over 1 plus x over e to the x minus 1. That's a common denominator. 1 minus 1 is 0. Minus x is minus x. 1 plus x over e to the x minus 1. Now this denominator can come down to the bigger denominator. I call it bigger, but it means like I like to draw a big fraction bar to help me keep track of things. Limit as x goes to 0. Minus x over 1 plus x e to the x minus 1. That's not good. That's still 0 over 0. Because 0 on top, and then e to the 0 is 1, minus 1 is 0. So that's actually still indeterminate. Where does a 1 plus x squared come in? Oh. Gotta run, but you'll be back? All right, Arun, thanks so much for hanging out with me. Yeah, have a good day or good night. I bet good night based on your name, so glad to hear it. What the heck is happening with this problem? Oh, maybe they derived it again. That's where the 1 plus x squared comes from, I bet you. Because these minus 1s will go away, and that'll make things a lot simpler. So at this stage, you're allowed to use L'Hopital's again, because 1 over 1 plus 0 is 1, minus 1 is 0 on top, e to the 0 is 1, minus 1 is 0 on the bottom. So you have another indeterminate form, so I think you L'Hopital's it again. Hey, Hirban. I'm good. How about you? Okay, so when you L'Hopital's the top there, 1 over 1 plus x derives to minus 1 over 1 plus x squared. Minus 1 derives to 0. So over e to the x is e to the x, minus 1 is 0. This will not give us indeterminate. Okay, good. Minus 1 over, I'm going to turn it into one bigger fraction, just make it basic. You don't have to, you can just plug in 0 from this stage 2, but doing this makes me happy, so I'm going to do it. Plug in 0 to this, 1 on top, well, the minus sign too. 1 on top, 1 plus 0 is 1, squared, 1 squared is still 1, e to the 0 is 1, so we just get negative 1. Okay, that's easy enough. Well, once I figured that part out, it's easy enough. Okay, so let's go back to the post and answer their question. IBS struggle. Oh, that sucks. I don't have it, but I bet it's really annoying to deal with. Capitals. Roll again. A little bit of stoicism help. All right. If it works, it works. You try to take the limit from your last step. You get 0 over 0. Use the rule again. So you have to use LH again. And I got use of it. Okay. Nice problem. It works for boys and girls, you know. I don't know why you wouldn't. F of t equals cosine sine of 5t plus 7 ln 1 plus t. You need to find the first order of it where t of 0 equals 0. And second order. Ooh, okay. They gave you a really annoying function. Let's look at the formula. Taylor series. You actually could probably make it from like super simple. Yeah, I mean, you get that, of course. I bet there's a way to do it without trying to derive it for yourself. Like you could or like I bet you can use like the pre-calculated like commonly used Taylor series figured out, but let's just do it ourselves. So I believe a first order is the first two terms, even though it's only the first order, and the second order is up to the third term. That always kind of gets me, but yeah. Okay, so and you're doing it about t equals 0, okay? We have another complex analysis fact, this thing called essential singularity. So it's your analytic function. The image covers all but at most one point infinitely often. Huh. That's interesting, Buddha, but no ways to go. So far, I agree. But Ben Stormzy, welcome in. Okay, so we have. Let me actually pin. Actually, no, I'm just gonna rewrite it. He's a friend. It's all good. The more, the merrier. I can't talk. It's here to see you cook my Ben's problem. Hopefully, I can. I know we and Ben Stormzy. Oh yeah, two Bens. We have f of t equals cosine of sine of 5t plus 7 ln 1 plus t. Oh, thanks for the follow, Ben Stormzy. You are number 275, so follower goal achieved. Thank you so much. going to set a new one after the stream. There's a reason why it still says 270. Oh, now it's 275. Just took a second to update. Hell yeah. Wasn't on that 300. So we need the first order and the second order Taylor polynomial here. So for the first order, we need f of 0. What the heck did I just write there? My mind was already on the plus sign. Plus f prime 0x. So we're going to have to derive that. It's going to be annoying, but it could be worse. The second order, actually, I should use t's, right? Just to keep things consistent. Second order will be the same thing, but we'll go out one more term. I keep on writing it wrong, dude. I promise you I'm not this horrible at math. I'm just horrible at writing and keeping a straight line of thought. F double prime of 0 over 2 factorial t squared. Okay, there. So f of 0, we could just plug in 0 to here. Sine of 0 is 0. Cosine of 0 is 1. So 1 plus ln of 1 plus 0 is ln of 1. ln of 1 is 0. So we get 0. So that's actually our first term done. Oh, wait, what is that? Oh, Benjamin Feingold's emotes? That's funny. Okay. Let's find what f prime of t is so we can get the second term for both of these. So again, we're going to need some chain rule here, and it's going to be annoying, but we can do it. So for chain rule, I work from the inside out. So derivative of 5t is just 5. The derivative of sine is cosine of the original. The derivative of cosine is negative sine, so I'm going to stick a negative sign in front. Into sine of 5t. Oh, that's going to be annoying for the second derivative, dude. And then the derivative of ln is 1 over ln. So we get, or sorry, it's not 1 over ln, it's just 1 over the inside. 1 plus t. Okay. So I hope that makes sense for getting the first derivative. We do need to plug in 0 to get the actual value. And please slow me down if I'm going too fast. No worries, Ben. So the sine of sine, basically I did the chain rule from the inside out, so I started deriving the 5t, so that's where the 5 comes from. I derived the sine of 5t, which is where this cosine comes from, and then this sine comes from deriving that cosine, and the inside still stays the same. So I derive the cosine into negative sine, so put the negative in front, and you get sine of a sine, which is annoying, but it's valid. Yeah. So now we need to plug in 0 into this monstrosity. Actually, it'll be a little bit easier because I'll start with this sine part, because 5 times 0 is 0, sine of 0 is still 0, sine of 0 is still 0, 0 times anything else here is just 0. So the first part is just 0. Over here we plug in 0, we get 7 over 1 plus 0, which is just 7. Not too bad. So already for the first order, we can answer that question because we have everything we need. F of 0 is 1. F prime of 0 is 7. So that's our first order approximation right there. The second order, we're almost there because the first two terms are going to be the same, but we need to go one more out and derive it again. One sec for the cosine. Oh yeah, sure. I skipped over that because I figured out that the sine part was just 0 anyways, but that part would be negative 5. You're right about that. Yes. And then Yeah, I'm sorry, because I was going a bit quick, but you end up with -5 for that part, and -5 times 0 is still just 0. So I was using some tricks just to save myself some mental math, but it's all good. I've done these problems a bunch of times, so I like I found the tricks, but yeah, this stuff isn't easy. So even though I'm doing it quick, yeah, I have the routine down. Um, let's do f double prime. So we're gonna take this line and derive it again. And this is gonna be a whole mess because we have a product rule here with the cosine and the sine. And the sine part has a, the triple chain rule again. So let's just take this piece by piece. Let's start by deriving the -5 cosine part first for our product rule. So -5 cosine 5t, the cosine derives to negative sine, so the sign will flip. And by chain rule, we multiply by 5 again, so we're going to get 25. So now positive 25 sine of 5t, and by the product rule, this second part stays the same. Sine of 5t. And now for the second part of the product rule, we need to derive this part and keep that part the same. So I'm gonna I'll keep a minus sign here. It might flip as we do the derivative, but that'll be easy to fix. We are going to have a 5t that gets derived and multiplied times that 5. So I'm going to write a 25. And then the original cosine of 5t, because that's not changing. And then now we'll derive this sine of 5t. Well, we already derived the 5t part, but now I'll derive the sine part to get cosine of 5t. And then I'll derive the outside sine to get times cosine of sine of 5t. So that's why this is a mean problem, because you have a whole mess of a function here. And I didn't make enough room to get that part, but I'll write it down here. Deriving that, actually it's going to be a minus. Deriving 7 over 1 plus t is, it's basically 1 plus t to the power of -1. And so you use your normal exponent power rule with derivatives. So you bring the -1 down in front. So it'll be minus 7 over 1 plus t squared, because that's 1 plus t to the -2 now. -1 minus 1 is -2. But I write it as +2 because it's on the bottom there. So I hope that part makes sense. I hope this entire thing makes sense so far, rather. The process, like, of just like deriving it twice and plugging in is like simple enough, but the actual like deriving isn't. It does? Okay, good. So now we have to get f double prime 0.
Son of a bitch. Stole my
Thanks so much. I really appreciate that. I haven't gone to the answer yet, so that's even better. Like now we just get the wrong answer or just quit. No. Thank you. I really appreciate the sub. So yeah, let's take this ridiculous thing and plug in 0. We should get a lot of things that turn out to be 0. In this first one, we'll get sine of 0 is 0, and 0 multiplied by anything is still 0, so let's just ignore that first term, or I'll just write a 0 for it. You're 11. That's already much more help than you got from your lecture. Oh, glad to hear it. Okay, so for this second term, I wish I left myself more room to write it on one line, but I'll start with this part. Sine of 0 is 0, cosine of 0 is 1, cosine of 0 is 1, cosine of 0 is 1, so 25 times 1 times 1 times 1 is minus 25. And then that plug in 0 minus 7 over 1 is just 7. Okay. So we get minus 32. Perfect. And now we just plug into the formula up here, and we got our second order approximation. So 1 plus 70, it'll be the first order the same as the first order. And then minus 32 over, this time we get the factorial coefficient as well, so we have to remember about that. 32 factorial is just 2, and 32 divided by 2 is 16. So I'm going to write 16 b squared. And that's our second order. And so I guess if you wanted to write like an equal sign, you might write like f of t is about with the double tildes to show that it's like an estimation. Or you could just write, I mean, depending on the context, you can just write equals as well. But so yeah, that's how I get the first and second order there. There might be a different way to do it or something like that, but this actually wasn't that bad as long as you're willing to deal with all the algebra in the deriving. Well, thanks so much. I appreciate having people coming in here asking math questions. That's what I really like. That's my goal for the stream, to like have people who are taking classes and helping them like get through their classes. So yeah. I forgot to mention, but I'm also happy to get into voice chat as well in Discord if that's something that would ever be helpful. I'll leave it up there for a little bit. Yeah, more. Oh yeah, sure. Hit me with them. That's fine if I can't do it for whatever reason. I'll just say sorry, I can't help, I guess. But can't answer these, but you don't know if they're correct. Okay. Complex numbers. Ooh, okay. If it's basic complex numbers, I can probably do it. If it gets too much in the weeds, though, then I'm not sure. Or if Buddha is around, he actually might be able to help too. But I guess we'll see depending on the question. Three minus 3i times 10 minus 6i in rectangular form. That seems like he would just multiply them. Then you get 30 minus 18, which is where your 12 came from. Minus 30i minus 18i. So yeah, the way that I would think to do it is the answer that you got. Oh, like solving that for z. I didn't do a problem like that. I assume the normal algebra rules would apply though. I can check that. Or I assume you could do like just a normal problem. Minus 5z plus 4iz equals 7 plus 4iz. Oh my god. plus 5i. So I gotta imagine you distribute the z in, and then you can like group like terms. 7z plus 4iz plus 5i. 4iz minus 4iz is 0. I'll bring, I guess, that to the other side. Minus 12z is equal to 5i. So z equals minus 5 over 12i, which is what you got. Okay, yeah. Oh yeah, I haven't done a problem exactly like that before, but I don't see why this wouldn't work, so... Hopefully that is the right thing to do. To double check. Oh yeah, it definitely seems right. If it's not right, there's some crazy thing that I haven't heard of, but I don't see why not with that. So if you have any more, feel free to keep them coming. In the meantime, I'll scroll a bit more around, see if there's questions online. Just so that there's something to do with the stream here. You'd have one more pretty sure sign. Okay. It's a fun one? Alright, yeah, let's see it. Thank you, Ben Stormzy. I try. So wholesome, me just stream helping people. I mean, I just really like helping people. Like, I used to work in a tutoring center, and just being able to have made someone's day a bit better was really nice. What do you do now? Right now, I'm unemployed, unless you want to count this as a job, but it doesn't make that much money. I'm just, I was working basically a boring office HR job that I didn't really like, so I decided to take time off and see if this goes anywhere. Divide PZ by DZ, then find all of its roots. Ooh. Oh, Ben, Stormzy, thank you so much.
I'll speak you in my prayers.
Oh,
A fine dark soul to you.
that's freaking one of my favorite quotes from Dark Souls. That's the first time I've gotten that alert actually on stream. But yeah, thank you so much, Ben Stormzy. I really appreciate that. Yeah, the Bens are here in force. um, so much people. Well, thank you for coming here and being supportive. It helps me keep doing it a lot. Z cubed minus 8 z squared plus 17z minus 30. D of z is z minus 6. So divide pz by dz, then find all of its roots. Okay. So pz over dz is, oh, I wonder if this is going to factor. I assume z minus 6 is going to be a root. Otherwise, I don't know what this problem is doing. 8z squared plus 17z minus 30 over z minus 6. So I guess we can do long division here. There's probably a trick to factoring this cubic. Well, you can't really group it. I guess let's try long division and see how that works out, even though it's kind of a pain. factor with imaginary numbers? Oh, that's something that I didn't learn how to do. Is there like a trick to doing that with imaginary? Or I don't know how you get the rest of the polynomial, I guess. Either way, I kind of want to try it just like the long division way and see what happens, but if you are able to, you can help me with that when we get there. Oh, okay. So I hope the long division is the right first step then, but if there's a different way to do it, I'd really be I definitely would be interested to hear it. Or like from like this step. So right here, we want to make the z cubed match with the z, so we're going to multiply by z squared to make that z cubed. So z squared times z is z cubed, minus 6 times z squared. I wrote cubed again. Minus 8z squared minus negative 6z squared is negative 2z squared. Drop down the 17z. Now I want to make negative 2z squared match with z, so we're going to subtract 2z. So minus 2z times z is minus 2z squared plus 12z minus. That becomes 0. That becomes 17 minus 12 is 5. Minus 30, could drop that down. Oh, and this becomes, that is the only way that you've learned? Oh, okay. You probably do synthetic division too, but that's basically the same thing. So this one, it is going to match up nice because 5z will match with z minus 6. So we'll do plus 5. 5 times z is 5z. 5 times negative 6 is negative 30. So that matches up perfectly. We get no remainder there. Wait, I'm going to come down here and write my equal sign. So we end up with z squared minus 2z plus 5. And the question was to find the roots of this result. So you got the first step? Okay, good. So when we find the roots of this, we need to set it equal to 0. So from this step, you said we can factor with imaginary numbers. It makes sense that I don't have imaginary roots. I don't know how to, like, is there a different way to factor other than quadratic formula? First find the discriminant. Okay. So the discriminant of this is going to be b squared, so negative 2 squared, 4 minus 4ac, a is 1, c is 5, 4 times 5. 4 minus 20 is negative 16. So that negative 16 for the discriminant is why we get imaginary roots, because you're going to take the square root of the discriminant and square root of a negative gives imaginary. A different version of quadratic formula. Plus or minus I square root. Is there the minus sign in front of the d there? If you already have the I? So if we use the quadratic formula here, minus b is positive 2. Let me write this bigger. 2 plus or minus, you said I root minus d. Oh, minus a negative. Plus 16. Okay. That makes sense. So I was confused because if the I was already there, then why would you add in another negative sign? But I think the negative sign cancels out with the negative sign you get there. So I think it really is the same formula. It's just a little bit like geared towards complex results. But yeah, oops, I just poked my whiteboard. But the square root of 16 is 4. So you can do 2 plus or minus 4i over 2. There's a common factor of 2 here. So it's 1 plus or minus 2i. Slight change, so it makes more sense. Yeah, I mean, you can do it with the normal equation too, I would think. It's just, if you want to use that equation directly, it saves you a step, I guess. Yeah, that's a fun problem. Thank you for sharing it. Right, I assume we got the same answer there, but yeah. No, thank you for coming by. You're all out of problems? All right. I'm glad to hear it. If you're all out of problems, that's it. That's good news.